Hi, this is Susan Bean, and this is the second part of our calculator instructions. Remember, our first part probably went a couple of hours, and we had gotten up to the chi-square distribution. So today what we want to do is finish up the calculator instructions. We're going to do the chi-square distribution. We'll do hypothesis testing, confidence intervals, linear regression, and ANOVA. It should take about an hour, just to let you know. So what you want to do is have your calculator handy, and also you want to have your calculator instructions, the ones you had received in your packet. Some of you have these calculator instructions in the book, but the calculator instructions in the packet are updated instructions. So it would be better if you have those, though if you don't, it's all right. So we'll start, and we'll first start by looking at the Elmo and looking at the keypad, a copy of the calculator. I have it here. This is your keypad as well as mine. I'm going to look at this a little more closely to let you look at the keys that we are going to be using. The keys that we're going to be using today are the mode key, the stat key, the second draw key, second distribution key, and the vars for variables key. And there's some others. We'll be accessing L1 and L2 and that sort of thing, but just so we know kind of basically what we're going to be doing. And we'll be using these arrow keys quite a bit. So I hope you have everything together, and we'll begin. So the page I'm looking at in the calculator instructions for the TI-83 is page 564. So if you'll turn to page 564 in the calculator instructions, I'll get myself set up here with my Elmo device and my screen. And I think we have it in. All right, so we're looking at page 564, and we're going to do the chi-square distribution. We have an example. It says degrees of freedom are 5, and we're going to do example 1 and probably example 2, all right? And example 3 is for you to do later. So we turn the calculator on, as it says. I'm following the instructions too. And the next step is to access second stat plot. So we press second stat plot. And what we want to do is press 4 and enter to turn off all the plots. So we'll press 4 and enter. And the reason we do that is so that other plots don't interfere with what we're doing. All right, the next step that we want to do is we want to set the mode. So press M-O-D-E, the mode key. And we're going to set it to 4 places, as it says. So we just arrow down and arrow over to 4, and then we press enter. And we always have to press enter to enter that value. And now it says all numbers will be rounded to 4 decimal places until changed. Then the next instruction says to find probabilities without graphing. Example 1, probability that this chi-square test statistic is less than 8. So we want to press second distribution. DISTR is above the vars key, so second distribution. We'll press that, and it says to arrow down until we get to the 7. So let's arrow down to the 7. And we could have pressed 7 also, but this first time through we'll just arrow down. It slows everything down a bit. And it says chi-square CDF. So let's press enter. And now we're set to do the chi-square CDF. So we want the probability that chi-square is less than 8. In other words, it goes from approximately infinity to 8. And so our lower bound has to be a very, very small number. So we're going to enter -1, and then we have to find EE. And the EE is above the comma. It's above the comma. So we press second EE. And what that does is it's going to give us a power of 10 when we finish. So we're going to enter 99. That number is -1 times 10 to the 99. That's a very, very, very small number on the number line. All right, going to the left. All right, so -1 times 10 to the 99. Then we want a comma, and our upper bound is 8 because we're finding the probability that chi-square, the variable, is less than 8. And then we have to enter degrees of freedom for chi-square, and it says here to enter a 5 and then we have to complete this with a right parentheses. So enter the right parentheses and then press enter. And we get the probability that chi-square is less than 8 is equal to 0.8438. Now, suppose we wanted the probability that chi-square is greater than 8. This is not in the instructions, in the written instructions, but I'm going to show you how to do that. We want the probability that chi-square is greater than 8. Well, all we have to do is put 1 minus, and then we can edit the function we have up here. This value has now gone into a variable called ants. All right? So we're going to do this again, all right? And so we'll press ants, which if you look at the enter key, ants is above the minus sign that's in parentheses, so we can press second ants. And that's the 0.8438. And again, ans, the variable, is above the minus key that's on the bottom that's in parentheses. That's next to the enter key. And press enter. And we get the probability that x, or chi-square, is less than 8. So now what we need to do, I'm sorry, not less than 8, greater than 8. Probability that chi-square is greater than 8. This is the probability that chi-square was less than 8. You'll notice that these things switch around sometimes. Okay, so you always can get the other probability. We call this left-hand probability when we have a less than, and right-hand probability when we have a greater than. All right, so let's turn to the next page, page 565. And it says to find probabilities with graphing. All right, the first thing we want to do is we want to press second draw. And draw is above the PRGM or program key on the keypad. All right, it's the third row down. So press second draw. And what we want to do is clear any drawings that might be in the calculator. So we'll press 1 for clear draw and enter. Or we could just enter, enter. That would work too. Now, in order to be able to draw a graph, just like on a piece of paper, we have to scale it. And we do that with the window key. So the next step following the instructions is to press window. And it says, first set the minimum and maximum values for x in the graph. So our minimum values are x min is 0, x max is 15, x scale is 1, that means a tick mark every unit, y min is negative, and remember to use the negative that's at the bottom of the screen with in the parentheses, negative 0.15, y max is 0.2, and y scale, we're going to put a tick mark every 0.05 units on the y-axis. All right, the resolution is how it appears on the screen. We'll keep that at 1. So this is what we need to have in order to see our graph. Now the next step after we do that is to press second distribution, and then it says to go down to C shade chi-square. All right, so first of all we have to go over to draw. So we want to press the right arrow for draw, and then we can either enter the 3 for shade chi-square, or we can arrow down to it. It doesn't matter. And enter. All right, now we have to put in the lower bound, and we want to set this time the lower bound to 4. We have to put in a comma. We're shading the probability that x chi-square is greater than 4, or figuring out that probability and looking at it in a shaded graph. So our lower bound is 4, and our upper bound is infinity, so we'll put a very large number in. So if we put 1 second EE 99, that's 1 times 10 to the 99, a very large number, comma, the degrees of freedom are still 5, a right parentheses, and we'll press enter. And we should get a shaded graph. It starts to draw our chi-square graph. Notice it's skewed to the right. It has this nice asymmetrical shape, which I like. All right, and that's the probability that chi-square is greater than 4. And it tells us that the probability, this shaded probability, is 0.5494. It's this area. Our lower bound was 4, and our upper bound was 10 to the 99, and the degrees of freedom are 5. So there's a lot of information on this graph. All right? So the next page, 566, is for you to try later on. It's always good to do these instructions with me, the instructor, and then later on go back to them and do them over and do the other examples we don't do. Now, let's just quit out of this. What I'm going to show you next is a little program. It's not in the instructions. You will be getting the instructions over the listserv and through the teleclasses later on when we get to chi-square, when we're at that point. I'll be putting them up on the listserv. This is a little program that TI kind of forgot. It's a goodness of fit test, and it's a little program that I wrote for the calculator. So the way we're going to access this program is we're going to press the PRGM key, and all you're going to do right now is watch. Watch me do it. And then later on, I'll give you the program. All right, so you press PRGM, and notice we have this program, and we just want to execute it, and we want to execute number 1, so we'll press 1, all right, and enter, and I get some information here. I get the degrees of freedom are 4, and I get that the test statistic chi-square is 17.4028, and I get the p-value is 0.0016. Now this program assumes I have information in the L1 and L2 lists, which I have. I had those ahead of time. And so that if I wouldn't have that information in L1 and L2, I would get an error. All right, but in the next couple of weeks, I'll be putting this up on the listserv and getting your attention for it, and you can actually do the little program yourself. It's sort of fun to be able to program. I'd never programmed this particular calculator before this little program, and it really wasn't very difficult, so you'll have the instructions. All right, now let's turn to page 567. Page 567, we see a contingency table. Contingency tables were first introduced in Chapter 3. We used them to do probabilities. They were a very nice tool for probabilities. Now we're going to do what's called a chi-square independence test. And what this test involves are 2 factors. And it's a chi-square independence test is a hypothesis test. And the hypothesis test, null hypothesis says, are these 2 factors independent? In other words, are the number of hours of work per week and the age of the worker independent factors? In other words, does age matter when it comes to number of hours per week? Does it matter or not? When we say they're independent, we say that the factors do not matter. If we say they are dependent, then age depends on the number of hours of work per week. All right, so this is not a difficult test. So what we'll do now is switch back to the Elmo, and I cleared off what I had. And what we want to do in order to do this test is press second stat plot again, and you can't do this enough, and press 4 to make sure we turn off all the plots again. And then we want to set the mode to 4 decimal places, and let me check. I have mine set to 4. If you don't, if you played with the calculator in between times, you want to arrow over to 4 and press enter. And now what you want to do is you want to access the matrix key, which I didn't mention. If you look back at this keypad, the matrix key is right here, right there. That's the matrix key. All right, so we're going to enter this as what's known as a matrix. And some of you may know about matrices, and some of you may not. All right, so press that key. And then it says to arrow over to Math, and then arrow over to Edit. All right, so we arrow over to Edit, and we press enter. All right, now it says this is a 3-row and 3-column matrix. Notice that in the data we have, excluding the totals, 3 rows and 3 columns. So what you want to do at this point is enter a 3, enter, and enter another 3 if it's not in there. And I would imagine for your calculator it's not in there. All right? And then what you want to do is enter the data. All right? Now I've entered it already, but I'm going to enter it again. So we're going to start reading the first row. And the first row is titled 20 through 30, age 20 through 30. So we want to enter a 10, 60, and a 30. So we'll enter 10, enter, 60, enter, 30, enter. Then we want to go down to the next row, and we want to enter, we press 5, enter, 50, enter, 45, enter. And then we go down to the next row automatically, and we press 10, enter, 40, enter, 50, enter. And we've entered the data. We don't enter the totals. The calculator will automatically do that for us. All right, so after we get all the data entered, it says to press Stat. I'm near the bottom of the page. Press Stat. And then go over to the Tests menu. So we'll press Enter, Enter. And now we're at the Tests menu. All right. And we want to go down to where it says See Chi-Square Test. So we can arrow down. We'll just arrow down to where it says See Chi-Square Test. Remember, the chi-square is that little symbol that looks like an X. It's actually a Greek X, if you want to call it that. All right, we want to do that, and we want to press Enter. All right, now we want to arrow down. Notice it says Observed matrix is A. That's the data we entered. Expected matrix is B. The expected values, the e-values, we call them, are those values that we would get if the null hypothesis were true. In other words, if the two factors, number of hours of work per week and age, are independent, if that's true, that would be the null hypothesis, then we would get the expected matrix or expected values. So we'll arrow down to calculate, turn the page to 568, and press Enter. And we should get the chi-square test statistic is 11.2. That's the test statistic to calculate the p-value. And the p-value is 0.0244, and the degrees of freedom here are 4. We want to interpret this as, again, the chi-square test statistic is 11.2. The probability that chi-square is greater than 11.2, the p-value is 0.0244. The test of independence is a right-tailed test, just like the goodness of fit test that we just did previously. It's always right-tailed. And the degrees of freedom here are 4. All right? So this is what we have. All right, now, we want to see the graph here. So to see the graph, what we want to do is the next instruction, press Stat, and arrow over to Tests. All right, go to Tests in the Stat menu, it says, and then arrow down to where it says chi-square test, again, which is C. All right, and then press Enter. And this time we're going to arrow down and arrow over to Draw. So it's the same almost, except we're going to do Draw. All right, now we press Enter. And it should draw us a nice little graph, and it should shade the p-value, which is 0.0244, and that's the probability that chi-square is greater than 11.2. And it gives us, nicely, this value that's cutting off the p-value, and it gives us the p-value, this area to the right of 11.2. All right? It's very nice. It does a very nice job. All right, going on to the next page is 569, and we're going to do linear regression. All right, it says the following data is real. The percent of declared ethnic minority students at De Anza College for selected years from 1970 to 1995 was as follows. The year 1970, the student ethnic minority percent was 14.13. In 1973, it's 12.27, and so on, all the way down to 1995, which is 53.1. The independent variable will be the year, the X values. The dependent variable, the student ethnic minority percent, will be the Y values. Y will depend on X. In other words, the student ethnic minority percent depends on the year. All right, now it says by hand you can verify the scatter plot below, and you can do that yourself. But we're going to do it on the calculator. So we should get this, this plot that has a linear feel to it. All right, we almost want to draw a line through it. All right, now the first thing we want to do is to enter the data and then to do the linear regression. And in the instructions it says, note, the TI-83 has a built-in linear instruction feature which allows the data to be edited. The X values will be in L1 and the Y values will be in L2. So the first step would be to turn the calculator on. So what I'm going to do is get out of this, clear this, and go back to where the calculator is turned on. If yours isn't turned on, please turn it on now. All right, now we want to, before we do anything, to make sure all the plots are turned off, and we've already done a plot, so we need to do this. Second Y plot, second stat plot, not Y plot. And we want to do number 1. I'm on page 570. No, we want, let me do it again. Second stat plot, and we want to do 4 plots off. All right? I want to turn all the plots off. All right, now we want to round to 3 decimal places this time. So let's press Mode, arrow down and over to 3, and press Enter. So now the mode is set to 3 decimal places. Then we want to press Stat. All right, we want to press Stat. And it says to enter 4. So we're going to clear the lists for L1 and L2. So we'll put a parentheses, second L1, comma, second L2, and press the right parentheses, and then enter. And that will clear those lists. Okay, so we've cleared the lists. Now we're going to edit. So we'll press, I'm down at the line that says, after we've cleared the list, I'm down at the line that says Stat Enter. It's about the middle of page 570. So let's press Stat, and we want to edit. That's number 1, so we'll press Enter. And now I have nice clear lists. All right, so we have to go back to the previous page, 569, and enter the data, and enter the data in L1 and L2, remembering that the year is the independent variable. We'll go and list L1, and the student ethnic minority percent will go into Y2 and will be the dependent variable. So let's enter this. So we'll just go ahead and enter these values carefully. I will enter them. And notice they skip years. We just don't go use the years consecutively here. Okay. Okay, now I always go back up and I check. I make a check that I did it right. Okay, it starts with 1970, 73, 73, 76, 79, 82, 83, 86, 89, 92, and 95. All right, so I'm going to go over to the top now and put in the Y values. And I can just put in the Y values as I see them. And again, I'll go back at the top and I always check them to make sure I didn't make a mistake. So 14.13, 12.27, 14.08, 18.16, 27.64, 28.72, 31.86, 33.14, 45.37, and 53.1. And notice our number of decimals is set to 3, just like we told the calculator. All right, so we've done that. We need to turn back over to page 570. And it's in the middle of this page. It says after the data has been entered. Now we want to do second catalog. And the reason we're doing this diagnostics on is that we want to display the correlation coefficient. By default, the correlation coefficient R is turned off. So we'll press second catalog. All right, now look at the keypad and find 0 down at the bottom. Catalog is a second key. So you want to press the yellow second key and catalog. And then what we want to do is we want to arrow down, just arrow down to where it says the D's. We'll just do this quickly. And diagnostics on. So we just arrow down to diagnostics on and press enter. And then press enter again. All right, now R and R squared will be displayed during regression calculations. R is the correlation coefficient. All right, now the next step following the instructions is to press stat. And then we want to access linear regression in the form of y equals a plus bx. So press the right arrow key and calc. And then you can either arrow down. Let's arrow down. It says to press 8, but let's arrow down so you see it. That says linear regression, a plus bx. So we want to press enter now. And then we want to press enter again. Okay, so we have the linear regression equation, a plus bx. A is the y-intercept, b is the slope, and we see r squared, and r, the correlation coefficient, 0.961, displayed. And it says here, this means the line of best fit, the least squares line, is y hat equals negative 3176.909 plus 1.617x, and the correlation coefficient R is 0.961. I'm reading the bottom of page 570. All right, we're going to display the linear equation a little later on the screen. I'll show you how to do that. All right, now, during linear regression, we always do the scatter plot, and then we try to do the line of best fit. So I'm on page 571, and it says to see the scatter plot, press second stat plot and press enter to access plot 1, and we have to turn plot 1 on, so we want to press enter. Our cursor is blinking on, so we'll press enter to turn it on, and then we're going to use the arrows to go to the first picture. So we're going to go to the first picture. So just use the down arrow key. If you happen to hit the right arrow key, then hit the down arrow key and you'll be on type, and it will be the first picture, and the first picture is just a scatter plot of just points. And then press enter so that the cursor is blinking on that. And then it says use the arrows to go to the X list. All right, so if you didn't have L1 displayed here, you go to the X list and press second L1, enter, and then press second L2 for the Y list. And then you could change the marks here. Right now I have the mark for a point as a little box. You could change it to a plus, or you could change it to a dot, but the little box works pretty well, so we could press enter there. All right, and then we're finished with that, and we'll press, as it says, second stat plot. And it says use the arrows to turn off the remaining plots. So if the other plots were not turned off, what you'd want to do is go down to those plots, and that one's turned off. So what I could do is go back up because I turned them off, I think. All right, go back to plot 3, press enter. That plot is turned off. So all the other plots are turned off, so we're fine. All right, so press window. All right, and now we want to set X min and X max and that sort of thing. We want to scale the X and Y axes. And we're looking about the middle of the page of page 571. And we want to set X min to 1970 and X max to 2000. And we want to do the spacing of the tick marks every 10, not every 1. And Y min is going to be negative 0.05, just as it says. and y max is going to be 60, and we'll space the tick marks on the y-axis every 10 also. And we'll keep the resolution at 1. That's fine. Now it says be sure to deselect or clear all equations before graphing. And to deselect the equations, we press the y equals key, which is at the top. And notice I have an equation there. It says if any equations appear, arrow over to the equal sign and press enter to deselect it, and continue until all equations are deselected. And if we would want to clear this equation, what we would do is arrow over to the equation, the right-hand side, and we could press clear, and that would get rid of the equation. And the equation is deleted. All right, now let's press graph, and there's our scatter plot. Nice scatter plot. All right, so we have a nice scatter plot, and we want to see the regression graph, and it shows one way in the instructions, and if you have the calculator instructions that were provided in your packet, I discovered a way later that we could really display this on the screen in a more efficient manner. And if you have that, you'll see it's kind of handwritten in my handwriting or my printing, and I'll slowly go through it. In order to see the regression graph, what we can do easily is to press vars, and this is in my handwriting, and vars is over in the third row next to the clear key, so we could press vars, and then what we want to do is enter 5 statistics. So let's just arrow down to the 5 so you can look at it. Arrow down to the 5 statistics, and then what we want to do is arrow over to where it says EQ for equation, EQ for equation, and then what we want to do is, see 1 is highlighted now. That's regression equation. That's the least squares equation, and so we could just press enter for regression equation, and we get the regression equation at the bottom. You read this as y hat equals negative 3176.909 plus 1.617x. All right, now to see the regression graph, we can press graph, oh, it's not going to do it right now. All right, what we have to do first, what we have to do first is press y equals, all right, y1, press y equals, and we're going to paste this function in here, all right? So we're going to go through this again. Sorry, but we did see the regression graph. All right, so what we want to do now is paste the regression equation in here. So let's press vars, all right, and we want to arrow down to 5 statistics and enter, and then we'll arrow over to equation, all right, and we'll press 1, and that equation was pasted in where y1 equals. So we had to go into y equals first to do that. All right, now what we can do is press graph, and it's going to draw our regression equation. Okay? So just to remind you, in order to do that little process where you press vars, you've got to press y equals first. All right? And the regression line is superimposed over the scatter plot. Now, down at the bottom of page 571, it says to see the residuals. All right? Residuals are the difference between the y value that is given in the data point and the y hat value that is calculated from the line. It's the difference between those two. All right? Those two values. Those are called residuals. So what we want to do is press second list, which is above the stat key, and it says resid will be an item on the menu. Arrow down to it. So we'll arrow down to it, and we'll press enter, and then enter a second time. And we see the residuals actually below the right-hand side of the line of best fit. This is the line of best fit. And so I'm seeing that was left over on the screen. So I'm seeing the residuals. If you cleared this out ahead of time, you won't see this. All right? You'll just see residuals. All right? So now we can arrow over in the residuals, and we can look at them. and we could run our little residuals test, which we won't do right now. But we can use the arrow keys to view them. And we could use our residuals to discover if we have an outlier or not. We won't do that here. We'll be doing that in the class. But we can at least view the residuals. All right, going on to the next page, it says to obtain estimates of y for various x values, there are various ways to determine estimates for y. One way is to substitute values for x in the equation. Another way is to use the trace on the graph of the regression line. Well, I'm going to try something. I haven't tried it before. First thing I'm going to do is clear out my screen. Now press y equals. All right, notice the equation we have pasted in there. That's the regression line, or the least squares fit line. All right, now what I want to do, I think, is I want to do second quit, and I want to write x equals, and I'm looking to find the equal sign here. I may not have one. I haven't done this before, so I'm just trying something. Some people would say that's brave of me on TV, but I don't see the equal sign here. So I can, on the TI-85 we have an equal sign, and it's easy to put equals. What I wanted to do was put x equals something, and then solve for y equals. Well, I think I can show you something else. I think I can show you, let's clear that out. Let's see if I remember how to do this. If not, we'll just scratch it like we do in a classroom. Press second calc. Calc is, now I'm not reading any instructions, everybody, and I haven't done this. I'm just trying something all together here. Press second calc, that's above the trace key, and let's arrow down to, oh no, let's not do that, second quit. That's not what we want to do. Press math, that's what we want to do. Press the math key. All right, and let's see. If we press the math key and we move the arrow keys down, we will get to solver. So press math and arrow down to solver. This is just something on the side. Press solver, and let's do this. Let's set our equation to alpha y 1, all right, alpha y1 minus our regression equation. So we'd have to do vars, we'd have to arrow down to statistics, over to equation, and 1. So we're pasting that in there. We're writing this, the equation was y1 equals, all right, so we're going to write it with 0 equals y1 minus the other side, all right? And let's press enter, all right? And now if you look at the enter key, all right, you look at the enter key, you'll see there's a solve, but before that, we want to make x the year, say, let me look at this. It's kind of fun to do this way. Make x the year, maybe, I lost my place. Let's make x the year 1997, all right? Then move the arrow key up to y, and notice if you look at the solve that's above the enter key, it's in that kind of teal green or turquoise, whatever you want to call it. So it's an alpha key. So press alpha, solve, and it should give us something. Yeah, it gave us a negative. So I probably did it wrong. Well, I'll figure this out and we'll do it in class. We should have gotten something, ethnic minority percent. We have a negative. I'm not sure why, what happened here. I'll have to check that out and we'll do it in class, okay? But that's how you can solve an equation. It's kind of a neat solver thing. We'll do that again in class, but that was kind of fun. I kind of like doing that. All right, for some reason I think I have my signs backwards, but like I say, I wanted to try it on TV. All right, so let's press second quit and clear everything out. And let's go over to page 573 and ANOVA. And the question is the average amount of TV watched per day the same for all age groups up to age 21? ANOVA is analysis of variance, and it's a hypothesis test. And what we're testing essentially is we're testing several means. In this case, what we're testing is 5 averages for 5 age groups. Okay, the averages are going to be the average amount of TV watched per day for the age groups 2 through 5, 6 through 9, 10 through 13, 14 through 17, and 18 through 21 years. In other words, youth. All right? Is the average amount of time watched per day, average amount of TV time watched per day, the same for all of these groups, or is it different? All right? This is an ANOVA test, analysis of variance test. So we're going to easily do this test. So let's see. We turn the calculator on. Mine's already turned on. And we access second stat plot. All right? And we want to turn off all the plots. So we actually want to hit 4 enter. So press 4 and enter. And all the plots are off. And we want to check the mode and see that we have the 3 decimal places. If you don't, arrow over to it and press enter. And now we want to access statistics mode. So we'll press stat, all right? And it says press the arrow down 3 times, all right? So we want to go to clear list and enter, all right? And we have to enter second L1, comma, second L2, and right parentheses. And we want to press enter. So we're clearing the list again like we did before. All right, now we want to press stat. I'm way down below where you clear the list. I am at the stat that's just below enter near the bottom of the page on page 573. And we want to press 1 for edit. And we're going to enter the data that's given in the table. And it says, enter the first list, the first column of observed data values into L1. Type in a data value, press enter. Continue in the same manner until all data values are entered. For negative numbers, use the minus that's at the bottom of the keypad that you see next to enter. Enter the second list into L2. Continue in this manner until all 5 list columns have been entered. So we're going to enter each column in a list, list L1 through L5. So let's start. So here we'll enter 2, 3, 2.8, and 3.1. And then we'll enter over, and we'll go to the second list. All right, and enter down. Then we'll enter 3, 3.5, 4.1, 3.4. And then we'll go over to the next list. 2.5, 3.3, 3, 4. And we'll go over to the next list. This is list 4. This is the 14 through 17 age group. 3, 2.8, 3, 3.1. And we'll enter the last age group, the 18 through 17-year-olds. 2.2 is the second value, 3, and 2.9. All right, now we've entered all the data in 5 different lists this time. This is the first time we've used 5 lists. All right, then it says what you want to do is press stat to enter statistics mode again, and go over to the tests menu, tests, and then it says to arrow down to F ANOVA. So let's arrow down to the F. F ANOVA, and we can press enter. And now it says to enter the list to be included in the ANOVA test. So we have to enter second L1, comma, second L2, comma, second L3, comma, second L4, that's above the L1, it's actually above the 4 key, and a comma, second L5. And then we close it with a right parentheses, all right? And we hit enter. And one-way ANOVA gives us the F, which is the test statistic. Remember, this is a hypothesis test of 2.657. The p-value, the little p, is 0.074. We have the factors, DFs are 4, and then we have SS, which is called a sum of squares, and MS, which is a mean sum of squares, and we have what's called the error, which gives degrees of freedom of 15. The degrees of freedom for the factor are known as the degrees of freedom for the numerator. The degrees of freedom for the error are 15 is known as the degrees of freedom for the denominator, and then there's sum of squares there and mean square and some other quantities. And we want to interpret this as the test statistic is 2.657, if we go back up here, and the p-value is 0.074, and the probability that f is greater than 2.657 is 0.074, the p-value. All right? There's other information that we may or may not use. All right? Now, let's go on to page 575, and we're going to do confidence intervals. All right, I'm going to clear my screen here. All right, we're going to do a confidence interval. We're going to tell how confident we are that a population mean that's unknown is between, say, two values. And we're going to get the confidence interval here. For these examples, it says find a 95% confidence interval for U, a 99 confidence interval for P with different values. All right, so we'll start again. We'll turn the calculator on. All right, and it's on, and the first example says, let's find a confidence interval, a 95 confidence interval for the unknown population mean mu when we know the sample mean x bar is 6, we know the population standard deviation is 4, and we know the sample size is 20. So we press stat, all right, we arrow over to tests, just like it says, and we press 7, or I'm going to arrow down. You can either press 7, or you can move down to where it says 7Z interval, and press enter, all right, and then it says Z interval calculates confidence intervals using Z-scores. A box will flash over stats. It says to arrow down and enter sigma equal to 4. Arrow down again. X bar, the sample mean is 6. And N is 20. And our level of confidence is 0.95. C level means confidence level. And then we want to just enter down to calculate and press enter. So our confidence interval for the unknown population mean mu, our 95% confidence interval, is 4.247 to 7.753. That says that I am 95% confident that the true population mean falls between those values. I am 95% confident. That's a pretty easy test, isn't it? It's kind of nice. All right, let's do example 2. We're going to find a 95% confidence interval for mu, but this time we don't know sigma, the population standard deviation. We know S, the sample standard deviation. So it's a little different test, but it works very much the same way. So we'll press stat again. We'll arrow over 2 times to tests, and then we're going to move down to 8 in the T interval, because this is going to be a T confidence interval. So we'll do the T interval this time for a student T. So we'll press enter. All right, again, our cursor is flashing on stats, and what we'll do is arrow down, and all we need to do, I think our X bar stays the same. We're going to enter a sample standard deviation of 4. Our N is going to stay 20. This time we're doing a T confidence interval. We'll move down to calculate, and we'll press enter. And our confidence interval changed a bit. To 3 decimal places, we can say we are 95% confident that the true population mean is between 4.128 and 7.872. But this time it was a T interval. We're using a T distribution. Okay? Now we're going to do a 99% confidence interval for a population proportion. I'm on page 576. 576. So we'll press stat, and we're going to arrow over to tests, and we're going to arrow down to where it says A, 1 proportion Z interval. So let's just arrow down all the way down to A, 1 proportion Z interval. All right, this is going to be a normal test. Test of a proportion is a normal test, or a normal confidence interval is what we're going to get. All right, so let's press enter. And it says it calculates confidence intervals for single proportions. Okay, we're going to arrow down. Now we're going to make x 45. This is the number of successes. N is 60. That's the total number in the sample. Our p prime or p hat would be 45 over 60. That would be the estimated proportion, which the calculator will calculate automatically for us. We don't have to do it. And we'll arrow down to confidence level and make it 0.99. And then we'll arrow down to calculate and press enter. So the confidence interval for the true proportion, the 99% confidence interval, is 0.606 to 0.894 when we have it set to 3 decimal places. The p hat is 0.75. You can see the little hat over the p, or p prime is 0.75. All right? So that's an easy test too. So let's go on. We have one more thing to do, and it's hypothesis testing. I'm on the last page, I believe, page 577 of what I'm going to do today. So please turn to that page, and we'll do a hypothesis test. This hypothesis test is that the population mean is 4. That's the null hypothesis. The alternate hypothesis says that the population mean is less than 4. This is a left-tailed test. All right, so let's press Stat. And we want to arrow over to test again. We're getting really good at this. And we want to do a z-test. So we'll press 1, and we're going to do a z-test. Our box is flashing over stats again, and we want it to be that way. So we want to make mu sub 0 4. All right, that's our null hypothesis, 4. And sigma, our population standard deviation, is going to be 2. Our sample mean here is 3.4. That's the information we get from our data that we take for this test. And then our n, our sample size, is 40. All right, this is a left-tail test, so we want to arrow down and over to less than mu sub 0. That's telling us we're doing a left-tail test. And then we want to arrow down to calculate and press enter. All right, so for this test, what we get is that the z-statistic, our test statistic, is minus 1.897 to 3 decimal places, the way we set it. The p-value is 0.029, and we're given the sample mean is 3.4, and n is 40. All right, so depending on what our alpha was, we could either reject or not reject the null hypothesis. It says here at the bottom, you may use draw to see the graph. You could try this again, and try draw, and make sure all the plots are turned off when you do draw, and also set window as a reminder. Well, that's pretty much the end of our instructions that we're going to do for this session. So this is Susan Dean. I hope you get really good at these instructions. I am sure you will, and I'm sure you'll enjoy doing them. So I'll see you in class.